Friends, today we are now going to study about the Lapesrate. That is one of the most important aspects of climatology. Lapesrate is the rate at which the atmospheric temperature decreases with increasing height, or the increases with decreasing altitude. That is the temperature decreases with increasing altitude, or temperature increases with decreasing altitude. So this Lapesrate that can help us to understand how much temperature is decreasing at a height. So we can say there are three conditions that may be observed. Sure, there are three conditions that are available. There is a uniform temperature at the surface and the troposphere, which is known as the zero Lapesrate. When there is a temperature decreases with elevation, which is known as the positive Lapesrate, and the temperature increases with elevation, that is known as the negative Lapesrate. So this temperature basically fall with the increasing elevation. There are two main important aspects. One is the atmospheric pressure. This atmospheric pressure, that is fall in atmospheric pressure, that implies the temperature also falls. And the concentration of the greenhouse gases. This concentration of the greenhouse gases like carbon dioxide, water vapor, etc. having a heat absorption capacity that will be decreased with increasing altitude. Therefore, the temperature is decreases with increasing altitude. So there are different types of lapsrate that we can observe in our environment. First one, we can say that the environmental lapsrate. The environmental lapsrate, that commonly also known as the which is very highly variable, or ELR, which is very highly variable and mainly affected by the radiation, convection, condensation, when the lapsrate is averaged out of the all places and times, it is called as the standard lapsrate also, and the average about it 5 degrees centigrade per kilometer in the lower atmosphere. The environmental lapsrate is observed by an upward moving radius node. Next, coming to the adiabatic lapsrate. So this adiabatic lapsrate, that is the change in temperature with pressure. Change in temperature with pressure. On descent through atmosphere, the lower layer are compressed under the atmospheric pressure. That is causes the temperature increases, and in case of the on ascent air cases, the air is expand as pressure is decreases. Therefore, the expansion reduces the temperature and aids in condensation of the water vapor. This condensation of the water vapor will reach the latent heat of the condensation in this process. So there are two types of adiabatic lapsrate. One is known as the dry adiabatic lapsrate. This dry adiabatic lapsrate is the rate of falling temperature with an altitude of the dry air parcel or unsaturated air rising under the adiabatic conditions. This dry adiabatic lapsrate is equal to 8 degrees centigrade per kilometer, and it is closely associated with the stable weather condition. And the another important lapse rate, which is known as the moist adiabatic lapse rate. This moist adiabatic lapse rate occurs when an air parcel that is saturated with water vapor going to rises, and some of the vapor will condense and release the latent heat of condensation or latent heat. The moisture adiabatic lapse rate is considerably varies because the amount of the water vapor, which is very highly variable in the atmosphere, and the average moist adiabatic lapse rate is 4 degrees centigrade per kilometer, and it also associated with the unstable weather conditions. So what is the importance of this lapse rate to study in the climatology? First, it helps us to understand that is the difference between the normal lapse rate and the dry and moist adiabatic lapse rate. That also help us to study the vertical stability of the atmosphere, and the lapse rate is of prime importance for the meteorologist to study about the type of cloud formation, tornadoes, thunderstorm. These are the features or aspects that we can study in climatology with the help of this study of the lapse rate. Thank you for watching this video.